The children, how
Hi,
are
sir.
you?
Fine, sir.
Right. Okay, just let's wait for a minute or two and then we will start. Okay. Good evening, everyone. Good evening, Lokesh. Okay. Let's just start now. Right. So, in the capacitor, we discussed about what the three type of capacitors, na? Parallel plate capacitor, spherical, and the cylindrical capacitor. So, in these three cases, the difference is what? The difference is the shape of the conductor, isn't it? The last one is the cylindrical capacitor. Just let's discuss a little bit about the uh, cylindrical capacitor, okay? And then we will discuss about the electrical circuits, okay? So cylindrical capacitor means what? Here the conductor is in the shape of what? The cylinder, okay? So the third type of capacitor we have is cylindrical capacitor, okay? So here the cylinders are what in the form of the conductors are in the form of what the long cylinder, okay. Let's say this is a long cylinder, okay. Inner radius of that one, let's take it r, and this is a long one, okay. This is a long cylinder here, and the outer one is also what a cylindrical shape. Let's call inner one as ri radius, and the outer one, let's take it as the r outer radius, okay. So again, if you give charge to these cylinder, what will happen? The field will develop, isn't it? And because of the field will be in this direction, in the radial direction, here everywhere in the radial direction of the cylinder. Because of the field, there will be a potential difference develop, isn't it? So how do we calculate the potential difference? So you see, field in this region is going to be how much? Lambda by 2 pi epsilon naught r, right? Field due to a long cylinder or very infinite cylinder is lambda by 2 pi epsilon naught r. And if you write dv here, what you will write it? Minus of E dot dr you will write it, isn't it? Let's calculate that potential difference. So dv equal to minus electric field is how much? Lambda by 2 pi epsilon naught r and dr. Let's integrate it. Now, if you look at when r is equal to r inside, the potential is something v1, okay? And when r is outside, the potential is something v2. So this v2 minus v1, if you calculate it, that is coming minus lambda by 2 pi epsilon naught and dr by r integration will be ln r. If we put the limit, r outer by r inner will come. And v1 is greater than v2. V1 is which potential? This potential. V2 is this potential. Okay. So V1 is a high potential na, because look at the direction of field. Field is always from which direction? High potential to a low potential. So V1 minus V2, if we calculate, we are getting V1 minus V2 as lambda by 2 pi and inner radius we have. So this is the delta V, isn't it? Now, once we calculate the delta V, then we can calculate the capacitance. Why? Because delta V is equal to charge by capacitance. So what is the delta V we have calculated? Lambda by 2 pi epsilon naught ln outer radius by inner radius. And what will be charge? Can I say charge is again going to be lambda into L? matlab we want to calculate the capacitance of some length L, right? Because it's an infinite cylinder, so infinite capacitance will come. So here, in case of cylindrical capacitors, what we do, we calculate the capacitance per unit length, not the complete capacitance. Okay. So this is C by. So if you simplify it, what will get cancelled? Lambda will get cancelled out, isn't it? So the capacitance per unit length of a cylindrical capacitor, how much is that? That is 2 pi epsilon naught ln outer radius by inner radius. This is called the capacitance per unit length of a cylindrical capacitor. Clear? So capacitance per unit length of a cylindrical capacitor is what? 2 pi epsilon naught ln r naught by r I, or outer radius by inner radius. Clear? Please tell me, clear the third type of capacitor? The third type of capacitor is the cylindrical capacitor we have. Okay, so these are the three type of capacitor depending on the shape of the conductor. Please tell me, clear up to this? Please tell me, clear? Hello, is this clear? Please tell me. Right. Okay. So let's now go to the electrical circuits. Electrical circuit means what? Now we'll discuss about the flow of charge in a conductor. Okay. And electrical circuit means we have to discuss about the electric currents. Okay. So current will be only flowing through what kind of material? The conductor material, है ना? Not through the insulator. Current can only flow through what? Current can only flow through the conductors. Conductor means what? Those type of material which has many free electrons available. Okay, if a material has large number of free electrons available in the material, then those materials are called as the conductor. So current will be always flowing through what? Only through the conductors. Okay, so let's discuss about the electric current. Okay, so how much current will be flowing? Okay, what will be the direction of current? These things we are going to discuss now. Okay, let's say there is a conductor of what? Conductor of area of cross section of the conductor is something A. Okay, and the length of conductor is something L. Can you tell me, in this conductor free electrons will be there, and in the absence of any external field, who will create that external field? So external field will be created with the help of what? The battery, isn't it? So in the absence of external field, how the electrons will be moving? Can you tell me? In the absence of field, what electrons will be doing? Electrons will be moving in the random direction, isn't it? What the electrons will be doing? Electrons will be moving in the random direction. Okay, because even there is no external field applied, no battery is connected, still the electrons is having the energy na. So because of that energy, what will happen? Electrons will be moving, not stationary. Okay, but when they will be moving in what? In all the random directions, not a specific direction. So what we did, we applied a battery here. Okay, we connected this conductor with what? With the help of a battery of what voltage? Of V voltage. This is what polarity of the battery? The bigger one is called as the positive polarity. The smaller one is called as the negative polarity. That means what? This conductor, this end will come at positive potential, this one will come at negative potential. Positive and negative means what? It means we have created an electric field inside this conductor. Okay. Now, what will happen because of this field? So, because of this field, all those electrons which were earlier randomly moving, now these electrons will start moving in a particular direction. What will be direction of motion? Direction of motion of electron will be opposite to the direction of external field. Why? Because electrons are negative charge particle now. Negative charge particle experience force in which direction? Opposite of the field. Okay, so electrons will start moving in this direction. So these electrons, what they will do at any moment, are they going to cross a section, cross a cross section area of the conductor? So how much electron, or better to say that how much charge is crossing per unit time through a cross section? That is called the current. Okay, what is the current? Current is amount of charge crossing a section of a conductor per unit time, that is called the current. This is called instantaneous current. And if you want average current, what you will do? You will write it delta Q by delta T, isn't it? Instantaneous means every moment it will be changing, and average means the net effect of for a larger duration of time, isn't it? So we want to calculate the instantaneous current due to this flow of electron. Okay, how do we calculate it? Tell me. Now, if I ask you, what is the force acting on the electron? What you will say? Will you say charge of electron into electric field? And if I ask you, what is acceleration of electron? So will it be E by mass of electron? Isn't it? E is the charge of electron, capital E is the field applied, and m is the mass. So due to this acceleration, it is moving. Okay. Let's say I'm thinking about the velocity of first electron. How much it will be? It will be u1 plus E by m into t1 will be there. V2 will be how much? Again u2 plus E by m into t2 will come. Like that, there are many electrons in this conductor. So if you sum it and take the average, how much it will come? So V1 plus V2 plus V3 plus V4, isn't it? And average of all those velocity is called what? That is called average velocity of all these electrons is called drift velocity. So U1 plus U2 plus U3 average, how much it will come? So think about U1, U2, U3. What are those? U1, U2, U3 are the velocity of all these electrons before field applied. And before field applied, they were in the random direction, isn't it? So the sum of U1 plus U2 plus U3 plus U4, the vector sum of all these random value will be how much? Zero. So that will become E by M, T1 plus T2 plus T3 plus T4 divided by 1. So that is called average time. And average time we represent it by what? The tau. Tau is what? Tau is called as the average time of collision. So what is the drift velocity of an electron in a conductor? E E by m into tau. Clear? What is this? This is called drift velocity. E is what? Charge of electron. Okay. Next. M is what? M is the mass of electron. What is tau? Tau is called average time of collision, because when these electrons will move, isn't it, they are going to collide with the next electron, or they are going to collide with the conductors, isn't it? So how much is the average time duration for which the electron move? That is called the tau, average time of collision, or it is also called as the relaxation time. Okay, average time of collision or relaxation time. Understood? And what is the E? Capital E. Capital E is the electric field applied. Who applied that field? So that field is applied with the help of what? Battery. Okay. Electric field applied by what? By the battery. Understood? So this is called the drift velocity. Please tell me, these are going to be important things, because whenever they will ask the microscopic part, means what is happening inside the conductor. So these will be needed. Now we want to calculate what is the current. Okay. So current is what? Is the current is amount of charge flowing per unit time. Let's say a small cross section I am going to focus. Okay. A small cross section I am going to focus. Dx length. Okay. So through that a small cross section, how much charge is passing in unit time? So let's say N is the number of electrons in unit volume. Okay. N is what? Number of electrons in unit volume. Area is the A and dx is small segment length. So can I say that N into A dx? What is that? Is it the number of electrons which is crossing that dx section? Please tell me. N is the number of electrons in unit volume. So how much electron will cross that A dx volume? बोलिए. Please tell me how much electron will cross that A dx volume. So number of electrons per unit volume into volume which it has crossed, right? So that is number of electron crossing that unit volume, isn't it? If that is number of electron crossing that volume, so what next we can do it? If we know the number of electron crossing that volume is n into ADX, this is number. If I multiply the charge of electron, will it become the charge crossing? And that charge crossed in how much time? Dt time. Look at this expression. Is this expression look like to you? NEA. And what is dx by dt? The electron crossed dx distance in dt time. Can I say that this is nothing but the drift velocity? Please tell me. So what is the current flowing through a conductor? The current flowing through a conductor is NEA into VD. Please tell. So this is the most important thing you can say, because rest whatever I am going to derive, that will come with the help of this equation only. Okay. So you can say that this is the most important part of your formula. Okay. Rest everything will come from here only. Okay. So understand what is the current flowing in a conductor? NEAVD. What is N here? Can you tell me what is N? N is called number of electrons. Okay, N is what? Number of electrons per unit volume. It is also called as electron density. Okay, number of electrons per unit volume is also called as what? The electron density. Understood? Or it is called carrier concentration, electron concentration. Okay, so these are the words they will use it in the question. Okay, so I is what? NEA into VD. Clear? Next thing, please tell me, up to this part is clear? I equal to NEA, and what is the drift velocity we have calculated? EE by M into tau. See this expression, I equal to NE square, है ना? NE square tau M A, and look at the electric field. See that. Who is creating that electric field? Is it created by electric field due to the battery? And electric field is created because of the potential difference created across the conductor. Na? So actually, how much potential difference we have created across the conductor? Did we create V potential difference across the conductor? Because battery potential is V, isn't it? So V potential difference is created across what length? Across L length. So can I say that V by L will be equal to electric field? Tell me, why did I convert it in this form? You see, N E square tau by M into A by L into V. And do you know one more thing about the current and voltage relation? What is that? Do I have I equal to V by R also, which is called the Ohm's law? So look at that. If you compare this equation and this equation, what you will get it? If you do the comparison here, these two equations, are you getting resistance equal to M by NE square tau L by A? Tell me. So the resistance of a conductor is how much? M by NE square tau into L by A. And you also call this thing as what? Rho L by A. Understood? So what is the rho here? R is the resistance. And what is the rho called? Rho is called as the resistivity of a conductor. Resistivity of a conductor. And resistivity has one more form of writing that. Conductivity, isn't it? Resistivity and conductivity, there is one more relation. What is that? Resistivity is inverse of conductivity also. Do you remember? Resistivity is what? Inverse of conductivity. Also, the resistivity, you can write it 1 by sigma as well. So if they ask you in the question, resistivity or conductivity relation, can you answer it? So resistivity is how much? Can I say this thing written inside this bracket? Can I say this thing is nothing but the resistivity, M by NE square into tau. Please tell, is this part clear up to this? So the resistivity, conductivity, we got it. Please tell me, clear? So that's why sometimes they will ask on what factor the resistivity depend, or on what factor the resistance depend. So resistance depends on rho, L and A. But resistivity depends on? It depends on mass of electron, which is never going to change, isn't it? Is the mass of electron going to change? No. Electron charge? No. But is the number of electrons per unit volume can change? Yes. How? For different type of conductor, different electron density will come, isn't it? Means electron density in copper and aluminium, will it be different? Please tell. The electron density in copper and electron density in uh, aluminium will be what? Different. And one more factor on which the resistivity depends is the temperature. Why? T. What is the tau? Tell me. What is the tau? Tau is the average time of collision. Na? Acha, tell me, if I increase the temperature, what will happen? Please tell me. If temperature increases, what will happen with tau? Can you answer it? Think logically and tell me what will happen with tau, average time of collision, if the temperature increases. Does it increase, decrease, or remain constant? Tell me. It decreases. Why it decreases? Because tau is the average time of collision, isn't it? When you will increase the temperature, energy of electron will increase, and if energy of electron is increased, that means its velocity will increase, isn't it? So what is going to happen with the electron? Now they will collide more frequently compared to the earlier case, isn't it? So with temperature, what happened? Temperature increase, tau decreases, right? And if tau decreases, you can see resistivity increases. And if resistivity increases, you can say the resistance of a conductor also increases. That's why what happened? Resistance of a conductor increases with temperature. Resistance increases, conductance decreases. Resistivity increases, conductivity decreases. Understood? So that's why for a conductor, what we can say, for a conductor, please keep in mind, I am writing the word conductor. Okay? For a conductor, resistivity and resistance. Okay? Resistivity and resistance. Okay, what happened? Increases, increases with increase in temperature. Increase in temperature. That's why what happened? Normally, when we have a conductor and you connect it to the battery, what will happen? It will follow a simple V versus I graph to be a straight line. It will behave like a ohmic conductor. What is a conductor called ohmic? When the conductor voltage versus current graph is linear, then it is called ohmic conductor. But as temperature increases, what happen? Our voltage increases, what happen? Resistivity increases, resistance increases, and it starts deviating from the straight line behavior. Okay, so at high temperature or at high voltage, a conductor will start behaving like a non-ohmic conductor. Is that clear? So sometime mathematically they will ask you what is the resistance relation with the temperature, how the resistance changes with temperature or resistivity changes with temperature. So temperature dependence of temperature dependence of dependence of resistance. What is that? It is means that with increase in temperature, what happened with resistance? So resistance is given as R naught into 1 plus alpha delta T. R naught is what? Resistance initially. This alpha is called as what? Alpha is called as temperature coefficient, temperature coefficient of resistance. Okay, and what is the delta T? Delta T is the temperature change. Okay, how much temperature you are changing, the more and more you will increase the temperature of the conductor, the more it will show the resistance. Its resistance will increase with the temperature. Okay, so this is the temperature dependence of resistance with the temperature. Clear? So this is up to what we have defined. Now we are going to define few more things. Okay, what is the current? Please tell me. What is the current we have got it? NEA into drift velocity. Can you tell me what is this current per unit area? NEVD. Can you tell me what is this? You know what is this called as? This is called as Z, and this is called as the current density. What is this called as? Current density. Current density means what? Current flowing through any cross section area. Okay, like this, if I have a conductor, okay, and some current is flowing through this conductor I, So current divided by the area of cross section through which the current is flowing, that is called the current density, J. Okay. And if you simplify it, you will see the current density can be written in some different form also. See that how current, can you write it like this? Current equal to, see that here, current we can write it now, Ne square tau by M A by L into V. Check it. Current per unit area, if I am writing N E, drift velocity E by M into tau. Check it. Current per unit area means Z. Look at that. Ne square tau by M. Ne square tau by M. What is that? Ne square tau by M. What is that? See, rho is equal to M by Ne square tau. So sigma will be Ne square tau by M, isn't it? So J can be also written as sigma into electric field. Current density can be also written as what? Sigma is what? Sigma is the conductivity. Okay, sigma is what? The conductivity. Clear? Understand about the current density? Current density is current per unit area. Sometime what will happen? Current will be given. They will ask you the current density. So you should divide it by area. You will get the current density. Sometimes current density is given in the question. They are asking the current. How do we calculate it? The current will be equal to J into A. When I will use that? We will use that if J is constant. J is what? Constant. And if J is variable, then what I should do it? Then I should integrate J into dA. And then we should get the current in the conductor. When I will use that one? If J is what? The variable. If J is what? The variable, then we should use it J into dA integration. One last thing we will discuss about is called mobility of electron. Okay, that is called the mobility. Mobility means what? Ability of electron to move in a conductor. How freely an electron is able to move in a conductor, that is called the mobility. Understood? The more easily it will be able to move in a conductor, the better will be the mobility, isn't it? So mobility, we write it by mu. What will be mobility? Mobility will be drift velocity by electron. Okay. Mobility will be what? Drift velocity by applied field, that is called the mobility of an electron in a conductor. Okay. So mobility represents what? It represents ability of electron electrons to move in a conductor. Okay, how easily it is able to move in a conductor? You see, same field you applied in two different conductors. Okay, one case we are getting more drift velocity. What does it mean? It means with the same application of field, one case electron is more easily able to move in a conductor. So in that conductor, electrons mobility will be what? Higher compared to what? The other conductor. Is that part clear? Please tell me whatever we have discussed till now. Is that clear or any confusion is there? Please tell me. So what are the important thing we discussed? Drift velocity, that is the first thing. Second, current. If you want to write it all of them highlighted one, keep in mind this. This is the drift velocity first. Second, current. Okay. Third, current in this format we have written, and with the help of that we got the resistance as rho L by A. Okay, rho L by A we got it, and rho is nothing but m by ne square tau. Fourth thing, how the resistance depend on the temperature. That is the fourth important thing. One more thing we defined is called the current density. Current density, we can write it in terms of current per unit area, or in terms of field also we can write it. That is the fifth one, okay? And the last one is the mobility of the electron. Understood? These are the six important things we have learned till now. So please tell me, are you clear up to this? What we have discussed? Please tell me, clear up to this?
Yes,
Tell
sir.
me, Charan
Yes, sir.
and Lokesh. Right. So now let's discuss some of the questions now, some of the examples now based on what we have learned it till now. And what is the direction of current? What is the conventional direction of current? Conventional direction of current is what? In the direction of flow of positive charge, or opposite to the direction of what? The negative charge. Understood? So if someone asks you what is the direction of current, if you see the positive charge is moving, then you will say whatever is the direction of positive charge, that is the direction of current. And if a negative charge is moving in a conductor, then what we will say, opposite to the direction of negative charge motion is the direction of current. Is that clear? So in a conductor, generally what moves? Proton or electrons? What are the free charge carrier? Proton or electron? Please tell me, which is the free charge carrier whose free movement will happen in a conductor? Protons or electrons?
Electrons.
Electrons, isn't it? Because protons are fixed to the nucleus. They can't move anywhere, isn't it? So the movement whenever happens in a conductor with the application of field, it is the movement of the electrons, okay? Because electrons are free to move in a conductor. Is that clear? Please tell me. It's a electron which moves in a conductor. So now let's discuss the next part. Let's discuss some examples on that, what we have learned it till now. Let's say an example I'm giving. There is a conductor, and this is the shape of the conductor. Okay, this is the shape of the conductor, and it is connected with a battery like this. Which direction the current will flow in this conductor? Let me call this is the section 1 and this is the section 2. So is the current is flowing from 1 to 2 or 2 to 1? Find first thing here, relation between the current. Okay, I1, I2. What is I1 and I2? I1, I2 are the current at two different cross section. Okay, that is the first thing. Second, drift velocity of electron at 1 and drift velocity of electron at 2. Means inequality form, equality and inequality form you have to answer. Matlab, you have to tell is the current is increasing as we go from 1 to 2, is the drift velocity increasing or decreasing, that is what you have to answer. It's a uniform conductor. Okay, it's a what kind of conductor? It's a uniform conductor. Uniform conductor means what? Its conductivity is uniform. Okay, third thing, what about the current density at 1 and current density at 2? That is the third thing you have to answer. Fourth thing you have to answer is what is the electric field at 1 and electric field at 2? Okay, so please tell me what will happen about these. Can you tell me about the current? Will it be same or different? If it is different, then which current will be more? Please tell me which current will be more? Please tell me which current is more, I1 or I2? See, is this the direction of current in the circuit? This is the direction of current, okay? See, current means what? Amount of charge flowing per unit time. We see whatever charge enters this cross section, isn't the same amount of charge is coming out this section in the same time? So here what will happen? Current will be equal. Understood? Current is what? Equal at 1 and equal at 2. Next. Second thing, if I ask you here, what about the current density? So current density is current per unit area. Now look at that. Current is same. Current is same. And if you see A1 is less than A2, area of cross section at 1 is less than A2. So what will happen? Current density at 1 will be greater than the current density at 2, right? Because if current is same, then current density will depend on the area, isn't it? Area of cross section. Area of cross section of 1 is less, so current density at 1 will be greater. Second section it will be less. Next, J and sigma, again there is a relation. What is the J and sigma relation? J equal to sigma into E. If it is uniform conductor, what does it mean? That means sigma or rho is what? Same throughout the conductor. Sigma or rho is what? Same throughout the conductor. So it means sigma is same throughout the conductor and J1 is greater than J2. So can I say that J1 is greater than J2 and sigma is same? So E1 will be what? Greater than E2. So I relation we got it, J relation we got it, E relation we got it. Now let's focus on the drift velocity. Okay. What is drift velocity? Drift velocity is, or better to say that, can we say here, current equal to current equal to NEA into VD, can we use it? Please tell me, current can we use it NEA into VD? Boliye. Or we can also write it drift velocity as E E by M into tau, we can write it, isn't it? Please tell me, current drift velocity can be write it E by M into tau. E is not changing, tau is not changing, M is not changing. The drift velocity is directly proportional to E. So E1 is greater than E2. So can I say drift velocity at 1 will be greater than the drift velocity at 2? So these are the things they ask in this question. For this conductor, you just needed to understand what are the different type of relation involved in this question to answer it. Tell me, is this part clear or not?
Yes, sir.
Right. Okay. Let's discuss the next example. In the next example, what is given to us? A conductor is given to us. Okay. A conductor resistance is what? Length is L and the area of conductor is A. Okay. Now, what happened? The rod or the conductor is stretched. Conductor is what? Is stretched. See the word. Conductor is stretched so that its length get doubled. Its length get what? Doubled. Okay. Find its new resistance. Find its new resistance. How many times the resistance has become? That is what they are asking in the question. So Whenever you get these type of question, length doubled, area half, these kind of thing, please see how the length got doubled or how the length got half. Okay, same question could have been asked. The conductor is given so that length got half. Uh, it depends on how the length got half or doubled. Why? Because if length is getting doubled due to a stretching, what will happen? In that process, if length get doubled due to elongation, can I say that area will get half also? Why so? Because the volume is going to be constant, isn't it? In this question, if I am stretching it, can I say the volume of the conductor is constant? So volume means what? Area into length is constant. So if length get doubled, can I say volume will get half? Sorry, area will get half. So in these type of process, what happened that uh, length only change given in the question. So don't think that sir resistance equal to rho L by A. Length got double, resistance got double. No, no, no. Length got double at the same time. Area also got changed, isn't it? So that's why here if I say length got doubled, the area got half. So when I will use the resistance formula here, rho L by A, new resistance if I want to calculate, resistivity will not change, na? Resistivity is the property of material. If a fixed conductor is there, then its a mass of electron not changes, है ना? Number of electrons per unit volume will not change, right? Temperature, these things are constant, isn't it? So if these things are constant, the resistivity did not change. Length got doubled. So can I say the new length is 2L? And what is the new area? A by 2. Why so? Because volume is constant. So what I got it here? Am I getting 4 times of rho L by A? So can I say the new resistance become 4 times of old resistance? So in this process, the resistance got 4 times. Understood? Please tell me. But if I say that conductor is cut half, cut into two equal halves, cut it into two equal pieces. So in these type of process, what will happen? Only the length will change, area of cross section will remain as it is. Is that clear? Please tell me, clear this one or not? So whenever they say length got half or doubled, please keep in mind what other thing happened. What happened with the other thing? Did it also get changed or not? Okay, let's see the next example. In this next example, what is given to us? Okay, please tell me, clear up to this?
Yes, sir.
Now, in this question given, resistance of a conductor at room temperature. Okay, at what temperature? Room temperature. What is the room temperature? Generally 25 degrees Celsius, isn't it?
27 degrees Celsius.
Okay, 25 degrees Celsius is 20 ohm. Okay, find its resistance. Okay, what is its new resistance when temperature is temperature is changed to 50 degrees Celsius. To solve this one, you will need a temperature coefficient of resistance. So the alpha is given in the question as 10 to the power minus 4 per degree Celsius. What is alpha given to us? 10 to the power minus 4 per degree Celsius. Alpha is not a very big value, okay? Alpha is the temperature coefficient of resistance. And if you increase the temperature, it's not like that the resistance will get doubled or tripled like that. Okay, with increase in temperature resistance gradually increases. So you can see, you will have just a rough idea that alpha is a very small value, isn't it? So alpha is a very small value. So with a small change in temperature, resistance also changes very small. Okay, so chaliye find it. What is the new resistance coming in the question? At this higher temperature, what will be the resistance of the conductor? Please check it. It's not a very difficult one. Tell me. Simple only. Please tell me what will be the new resistance of the conductor. How much it will come? Can I write it? Resistance at higher temperature will be equal to resistance at higher temperature will be equal to R naught into 1 plus alpha delta T. Initially, what is the resistance? 20 ohm. 1 plus. What is the alpha? Alpha is 10 to the power minus 4. And what is delta T? 25 to 50 degrees Celsius. The temperature changes. 25 to 20 into 1 plus. Is it coming 0.0025? Isn't it? The 20 into 1.0025. That much ohm will come. Okay, so very small change will happen. Okay, here in this question, charge flowing through a conductor is given to us. They're asking find current in the conductor. Find current in the conductor at t equal to 1 second. Okay, so how do we calculate it? Current in the conductor at t equal to 1 second. So we can write it. Current will be how much? Current we will write it as what? Current we want to find out. No, the current we can write it as dq by dt, isn't it? Charge as a function of time given to us. So dq by dt, if we do it, we will get the current, isn't it? So if we calculate that dq by dt, that is the differentiation needed, isn't it? So 3 tq differentiation. So 3 tq differentiation to 3t square. So 9t square will come plus 4, 8t will come plus 6. And when did they ask the current? They ask at t equal to 1 second. Let's put it t equal to 1. You know? So 1 squared, 8 into 1 plus 6. So 9 plus 8, 17 plus 6. That is the current in the conductor at that moment, right? At t equal to 1 second. So please tell me, clear up to this? Please tell me, Charan, Lokesh, both of you.
Yes,
Are
sir.
you right? So this is what we have about the current electricity or electric current part, isn't it? So next thing we will discuss it. Tomorrow class, morning time will be there, right? Tomorrow and Monday we will have the class, and 13 onward, 13 to 16 we will have the holiday. Okay, sir already messaged it also, na?
Yes, sir.
Yes.
Right. But these time also just practice some of the questions. Okay, right. So tomorrow and day after tomorrow, up to Monday, we will have the class. Then we will have the break. Okay. Right then, please tell me.
Okay, sir. Thank you, sir.
Right. So let's meet it tomorrow. Okay. Thank you so much and take care.